Okay, I just wanted to try and amplify something I explained very badly during our recent Perth meeting, I think. Let's try this. We can have in C++ a variable, an integer, I, equal to 1. We'll have another one, int j equal to 2. Double check compiles. Or build. Okay, we're happy with that. So it's a regular variable. I is a regular variable, so we can make I equals 5, I equals 10, and we have no problem with that. So it's a mutable variable, and we can have a constant integer, ijk, oops, a constant integer that's equal to 42. And then if we were to try to assign a different amount to k equals 1, and try to compile that, we have an error, because obviously it's a constant. Why are we not full screen? Okay, sure, whatever. So k is constant. Error. We can have a pointer to an integer. So we'll say int star, which is a pointer, p or pi, pointer to I, and give it the address of I, and we're using a so I think if we actually put pi, it's going to print the actual integer itself. I think Delphi does something. Oops. Alt F9, okay. It's happy with that, okay. And we're going to get a, okay. Well, I'm a little unhappy because the ID has jumped over to a different screen. But there we have the, obviously the address of a pointer. And it's the address of where I is. Oh, and we're back. Sure, that makes perfect sense. Alright, so we have a variable, a constant variable, a pointer to a variable. We can have a constant, and just indicate that pi can actually be changed because we can make it equal to the address of j. What is that? The address of j. We're going to have some line spacing and a bit more. And then we'll do the same thing again. Actually, normally we have to save our C files first. There goes the IDE again. Anyway, so we've got two different pointers. There was a pointer to one variable, and we were able to change it to point to a different integer. But we can also have a constant pointer, a const int star. We could call CPI, make it equal to the address of I, and then do the same thing here. We print out CPI. Well, we won't be able to do that. We try to change it and it won't work. CPI equal to the address of J. And Alt F9. You're gonna make a liner out of me. CPI is a constant star. This will be interesting. Okay, that works, so I did something wrong. Yay for me. Okay, let's see, let's print out the two values. Let's group these together. And run. So we've got I and J and I and J. Not what I was expecting. Okay, I'll have to look into that. As far as PI being appointed to an integer, then we can put some comments. Okay, so you're not doing Delphi. This says that PI can be changed as expected. And this says CPI can be changed not expected. Alright, next one is to say that dref of PI, which is the integer that the pointer points to, can be changed. So first we need to we're going to print out dref PI, which will be the value of I, and then we're going to change the value of the thing that gets pointed at. So it starts off at I starts off at 1. We're going to change it to 1 1 and print out the integer that's being pointed at. And run. forgot that we changed PI already. PI was pointing to J actually by the time we got to there, and we've changed the value by using the pointer to change the integer that it points to. So question remains, can we do that with CPI? Can deref of CPI be changed? Dun dun dun. So CPI at this stage will be, has been pointed at J, so it will have a value of, should be pointing to a value of what was 10. We've just changed it to 11. Whoa, hang on a second. Sorry, up here, J was 2. Yes, J was 2, and now we've just changed it to 11 right here because, okay, let's reset this example. We're going to put, again, PI back to being equal to the address of I. We're not Delphi. Use C++. Okay. And we're going to put CPI equal to the address of, okay, J. Let it be J. So we'll print out what CPI points to, which will be J, which should be 2. And if we change the thing that CPI points to from 2 to 22, we should see it come out that way. And we will okay, so this is telling us it's you can't change the thing that it points at. That would be a pointer to a constant integer, which I would expect to be written as int star const CPI. So this part, constant variable, and a pointer to a constant variable. Let's try introducing, so let's put that back how it was. We're going to have int star const I don't know, KPI, and it's going to equal the address of J. So this we don't like. Cannot change the value being pointed to. So naturally it'll print the same thing twice. Let's try the same thing. With KPI, the deref of KPI. And we will see what the compiler thinks about that. we are running. Okay, so we this part here is where CPI, the value being pointed to by CPI, was not allowed to be changed, but the value pointed to by KPI was allowed to be changed. Let's go back and take a look at that. So this said that the pointed to value is able to be mutated, and this one said pointed to value is unable to be mutated. Now, this is the exact reverse of what I thought how it should come out. Let me sit and think about it for a second. PI was able to point to either of two integers. PI, a pointer to int, can be changed. Oh, I got sidetracked here somewhere. We're meant to be seeing if the pointer can be changed. Did I check that? Did I test that? Star PI. Right, I got sidetracked. Sorry about that. So the whole point here is whether there's 2 points really. And this is kind of maybe not secondary, but it wasn't what I was after. The question is, if we set these pointers to point at one integer, can we make them point to a different integer, thus changing the pointer? So we'll take that. We're using CPI. Actually, we're just talking about CPI itself. I kind of went down a sidetrack there. Oops. Okay. CPI can be changed question mark. Okay, so at this point in time, CPI, if you dereference it, should be pointing to the integer I, as we put it up here. And then, if we try to change CPI to be the address of J, it shouldn't be allowed. And if we F9, why did you compile? What are you doing to me? So I need to make these examples a bit 1, 2, 3, 4, 5. Well, yeah, we'll see. CPI is allowed to point to two different integers. CPI is a const int star. KPI is an int star const. I'm showing my rustiness in this area. I spent a horrible 3 afternoons figuring out this sort of thing when I first tried to figure out C++ and then function declarations in C/C++, and that's no fun, I tell you. No, I should write. This is silly. Maybe explain what you're doing. Okay, so above here we had an ordinary integer, we had a constant integer, plain integer pi, constant integer CPI, here we've got a plain pointer, oh my god, plain pointer, constant pointer, pointer, plain pointer, point somewhere else, constant pointer, point somewhere else. Oh, hang on. CPI starts off pointing at I. Oh yes, and we changed it. Okay, that's good, that's good. Put PI back where it should be. The thing that PI points to can be changed. Sure, that's what a pointer does. And we want to know if the thing that CPI points to can be changed. CPI starts off pointing at I, although we just changed it to J. Okay, let's do all this again. CPI points to I, example 4. star pointer star pi const int star, yes. Not expected. We have print CPI, change CPI. We've already changed. Let's make it 100, whatever. And then print CPI. Get rid of this for a moment. And run. What are we unhappy with? Oh, sure. Perfectly reasonable. Where is the divider down here? There we go. Right. Cannot be changed. That's good. What was I doing before? Okay. A const int star cannot be changed. No, it can't be changed, but not in the way that I thought. Const int star pointer, which is really just pi. Plain pointer pi's target can be changed as expected. Constant pointer pi cpi's target can not be changed, and I don't know how I feel about that. And that, right, and we're going to do the same thing again with KPI. KPI is pointing at I. So I'll just do it the same way. We'll have KPI pointing at I. And this one is an int star const pointer, KPI. And its target can, we don't know yet, be changed. And then we can print what it points to, try and change it, and then print it again. And run. Oh, yeah, okay. We didn't do that. Alright, so this says we can't change KPI once we okay, that's the constant part. The constant pointer we can't, I mean we're giving it the same value, but error whoop, pointer cannot be reassigned. That is int star const pointer. one is a const int star. So in the C++ board, there's an argument about east const and west const. And some people would write this instead of const int star, they would write it as an int const star. Const. That looks horrible. But their argument is kind of related to whatever's happening here. And all that is in opposition to those two are the same. And int star const is different. Okay, so actually I think I may have figured this out previously in the past. I believe it's like this, that, so forget about the east const stuff, that const int star is like basically a constant integer, a pointer to a constant integer. Does that work out with what we did? And the other side is that it is a point. Hang on. Where do the brackets go here? This one down here, you can't change the pointer. And this one here, yes, okay, these are two meanings, I think. So const int, a constant target. Yes, the star means a pointer to a constant target, which means you can't change the target, which is why the error here for that one. So really we're looking at const int star, the target cannot be changed. Okay, and down here we have a int star const, which is saying that the pointer is the thing that's constant. You can't reassign it here, but we can change the target. So this should compile. So we're saying int star const, the target can be changed, and we're okay with that. Oh boy, this has been a trip down memory lane. And this should compile, I think, and run. Okay, so we have a plain pointer can be changed, a constant pointer, I have to have a relook at that one. The target of a plain pointer can be changed. The target of a constant pointer cannot be changed, but the target of a pointer to, no, was it? The target of a constant pointer can be changed. Oh boy, okay. Believe me, this is fun, right? You may not be convinced, but this is fun. Now, I'm not sure if we can write it like this in the compiler, like it's going to put up with these sort of shenanigans. Project build. No, doesn't like it. Okay, but that's what it means. Okay, if you're any sane person, that's what it means. This is a pointer to an integer that can't be changed, and this is a pointer that cannot be changed. So with this one, we should be able to we can't do that. Got to get rid of those. Get rid of those. So for this one, the integer is constant, so the pointed to value, the target is unable to be changed. The pointer itself can be changed. And this one is the reverse. The pointer cannot be changed, and the target can be changed. Okay, so we can do an extra line there. I did not think I'd be spending this long on it. Target can be changed. Pointer cannot. So here we are. Well, yeah. Let's just take that, put it in here. So KPI is the pointer. You can't reassign it, doesn't work, but you can change the target, and that's the proof. And in this case, I think we're going to do that first before the printing. This one, the pointer can be changed, and the target cannot be changed. And we see that that's changing the pointer right there, and it doesn't accept changing the target. And I don't think we need to check the case that you can have a what would it be, a const int star const called kk, which would be a pointer to an integer, and neither the pointer nor the target can be changed. It's like maybe it might point to the beginning of a dictionary or something, or beginning of an area of memory. The pointer won't change. Nope, that wouldn't be right. Some sort of constant value anyway. The location won't change and the value won't change. Alright. Boy. Run. Number 2. We're going to check out that number 2. I missed out the new line. Alright, what was case number 2? Constant pointer CPI. Well, that's kind of doubling up on what we... No? That's what we already figured out, right? That was 0.4. Yes, you can change the pointer. That's this. That's the same thing, exactly the same thing. So we don't need that example. And I completely forgot to say the whole thing that brought this up was that in Delphi we can have at the meeting we mentioned that you can have, you know, a function ABC that takes a of type integer that'll be copied. I mean, you could take a pointer to an integer. You can have a variable integer which passes in a pointer, but Scott pointed out that you can have a, how do you write it? A ref const k of type integer, however it is, I'm forgetting the details. And I was just making the point that in C++ you can have a value pointer, you can have a value, you can have a constant value, you can have a pointer to a value, a pointer to a constant value, you can have a constant pointer to a changeable value, and you can have a constant pointer to a constant value. And our const ref in Delphi is like the constant pointer to a changeable value. And I'm not sure that we have this one at all. Okay, wow, that was, thought that would take like 5 minutes. For what it's worth, hope you're still awake. Cheers.